Even though Java is a compiled and statically typed language, it manages memory for you. Unlike languages like C, C++, or Pascal, you don't have to explicitly allocate and deallocate memory whenever you create an object. The garbage collector is a major feature of the Java virtual machine that makes a lot of this possible. I'm going to describe how the garbage collector works and how little attention you as the programmer need to give it. When you create a variable that references a complex object, that variable is stored in the fastest available memory. But the object it references is stored in heap memory. There are two kinds of memory, stack and heap. The stack memory is somewhat faster, heap a little bit slower, but heap is more dynamic. When you create primitive variables, depending on their context, they might be stored in stack or heap. But complex objects are always stored in heap. And as long as any variable references an object in memory, that object will be retained. It won't be eligible for garbage collection. So if you create a variable and it points to a string, a date, an array, a collection, or any other complex object, as long as that variable can be addressed in your code, the object will be available. When all of the references to the variable expire, it's eligible for garbage collection. But it's up to the garbage collector process to decide when to do that. Variables that you declare within methods or within code blocks expire with that scope. Here's an example. Let's say I have a method named changeString, and within the method I declare a variable named localVar. That variable's scope is the method itself, and as soon as the method is finished executing, that variable is dereferenced. The value, the object it references, might stay in memory for a little while, but you can't address it anymore. And so it's eligible for garbage collection. And the next time the garbage collector looks for variables it can remove from memory, it'll find that one, and it might decide to remove it and reclaim that memory for future use. You can also dereference variables using the keyword null, all lowercase. No matter what the scope, if I execute this code, where I declare a string, and then I immediately set the value of that variable to null, I've dereferenced the variable. And again, the object might still stick around for a little while, but you can't get to it. The garbage collector runs in its own thread. Depending on the kind of application you're running, and depending on the hardware, the amount of memory, and other resources it has, you might detect a garbage collector process kicking in. You'll typically see it happen as a little pause in execution. The nature of the garbage collector is that it can destroy dereferenced objects and reclaim their memory. But it doesn't have to do that. The garbage collector is a smart process. It runs on its own, and you as the programmer can't do much to affect how it works. For example, you can't force garbage collection. You can't say, I want you to remove this particular object from memory. The most you can do is run methods that request garbage collection, but there's no guarantee it will happen, and there's no guarantee that any particular object will be destroyed. It's important to know what happens in Java when the Java virtual machine runs out of memory. Throughout this course, I'll be talking about exceptions. An exception is a runtime error. It's something that typically causes an application to stop execution or crash. It's sometimes called a fatal exception. If the Java virtual machine runs out of memory, that can cause this exception, out-of-memory error, and it can cause the entire application and the virtual machine itself to come to a screeching halt. To prevent that from happening, you should understand a little bit about managing memory in Java applications. First of all, minimize the number of objects you create. Understand when objects are being created, and see if you can find ways of recycling or reusing objects instead of creating new ones. If you're not sure whether your application is having trouble, you can use these methods. First of all, the runtime class has a method called maxMemory, and it also has a method called totalMemory. This will tell you how much memory has been allocated to the virtual machine and how much is currently in use. And you can set these values when you start up an application with command line options. This option will set the initial heap size, and this one will set the maximum heap size. And finally, This will set the heap size for new objects. You can experiment with these values and look in the documentation for more information about memory management in Java. It's also worth understanding that these techniques will differ from one platform to another. The recommended settings in a Java Enterprise Edition environment will be very different from those on an Android device. So again, check the documentation, ask other developers in your particular community for suggestions, and keep on experimenting with your applications as you fine-tune memory usage.